Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed and inspired. This problem was solved by three moment equations. So by slope deflection equations, determine the slopes at A and C and the slope and deflection at B. AI is constant. So let's solve this by slope deflection equation and verify answers to three moment equations. So take note that moment at A is 0 as well as at C. Then for the reactions, reaction at A times summation moment about C equals 0. Reaction at A times 10 equals 120. 120 over 10, so therefore this is 12 kilonewtons upward. Summation forces Y, so the reaction at C is 12 kilonewtons downward. So the moment diagram by parts, that's the expected elastic curve, call that delta B. And the moment diagram by parts would look like this. So let's make B as moment center. 12 times 4 is 48 and minus 120, so it goes down to negative 72, then 0 at C. Moment AC is to use 3EI over L times quantity theta near theta A. Since the chord joining A and C is horizontal because A and C are supports, so therefore delta C is 0 and minus fixed end moment at A minus 1/2 fixed end moment at C. Fixed end moment at A is M, which is negative 120 because this is counterclockwise. B 6 over L square, which is 10 square, quantity 2L, 2 times 10 minus 3B. While the fixed moment at C is, so minus 1/2 fixed moment at C is M, negative 120, A, which is 4 over L square, 10 square, quantity 2L minus 3A. So MAC, which is 0, equals 3EI over L10, quantity theta A minus 0, plus negative 120 times B over L square, quantity 2L minus 3B, and minus 1/2 fixed moment at C, which is negative 120 because this is counterclockwise. B A is 4 over L square, 2 times L minus 3A, 3 times 4. The value of this is negative 14.4, while this one is 19.2. So 14.4 minus 19.2 divided by 0.3 EI. Therefore, theta A can now be solved, negative 16 over EI. Because it is negative 16, it means theta A is 16 over EI counterclockwise. Because in slope deflection equation, rotation is positive clockwise, so it opposes, therefore this is counterclockwise. Next we have MCA. So MCA is equal to 3EI over L times quantity 3I over 10, quantity theta C minus 0 again because chord joining C and A is horizontal, plus negative 120 times A over L square, quantity 2L minus 3A. For the fixed end moment at C, it is M, which is negative 120, times A, 4, over L square, quantity 2L minus 3A, and minus 1/2 fixed end moment at A, which is M, negative 120, B, which is 6 over L square, quantity 2L minus 3B. B is 6 for fixed moment at A. The value of this is negative 38.4, while this one is positive 7.2. So from here we can solve theta C. 38.4 minus 7.2 divided by 0.3. So theta C is 104 over EI. Because it is positive, so it is clockwise from slope deflection sign convention. Then we set up moment AB, which is now 2EI, which is 0, and it is 2EI over L, which is 4 for AB. Quantity 2, theta A. This is theta A, then plus theta B, minus 3 times delta over 4. So let's assume that the rotation of the chord from A to B is clockwise. So this is delta B here, so that everything will be treated positive. So why 2EI over L? Why do we use 2EI over L? Because there is moment at B at the far end. So that's why we use this equation, 2EI over L. While if we have MBA, then we use 3EI over L because there's no moment at A. Then this is 2 times theta near, which is A, and we already solved theta A, plus theta B, which is unknown, then minus 3 delta B over 4. So the assumption is delta B is here, and the chord and this elastic curve is also below B, so that the chord rotates clockwise and delta B is treated positive. So setting up the first equation, theta B minus 0.75 delta B equals 32. Call this equation 1. Then we set up MBA and we use 3EI over L. 3 times, so MBA is, by the way, MBA is negative 48 because this is positive. It means it is counterclockwise, but clockwise moment is positive supposedly. So that's why this counterclockwise moment, 48 kilonewton meter, is treated as negative in slope deflection equation. Equals 3EI over L quantity theta B minus delta B over 4, or theta near minus delta over L, and delta is delta B and over 4 because the assumption is the rotation is clockwise. B is here. So setting up the second equation, theta B minus delta B over 4 equals negative 64, equation 2. Solving equations 1 and 2 simultaneously gives us the following values. Theta B negative 112 over EI, so that means theta B is 112 over EI counterclockwise, and delta B is negative 192 over EI, so meaning our assumption B is here, but because it contradicts with the results, so that means delta B is really upward above B. So delta B is 192 over EI upward, so above the horizontal axis of the beam. So that's it for this problem.